Welcome back again. So in this video we are going to discuss next questions of the same paper 970932 from the May June series 2020. So here's the question number 5. We have discussed the first 4 questions in the previous video. You can follow the link. I'll give in the description box. So the first part is express root 2x cos x minus root 5 sin x in the form of this. So root 2 cos x minus root 5 sin x in the form of r cos x plus alpha. So we know that if it is plus alpha, in the cos there is a cos a cos b minus sin a sin b. So we can take root 2 as r cos alpha and root 5 as r sin alpha. So from here we can say that r is going to be square of 2 root 2, that is 2, and plus square root of 5, that is 5, and hence r is equal to root 7. So from here we got r value as root 7, and then if you from these two equations only, if we square them, then we got r. If we are going to divide them, so we'll get r sin alpha over r cos alpha is equal to root 5 over root 2, and that is tan alpha is equal to root 5 by 2, that is we can write 2.5 as well, and from here we get alpha as tangent inverse of root 2.5. We'll calculate this in the degree because the answer is given in the degree, because this alpha is between 0 to 90 degree, and hence it is root 2.5. From the calculator it is coming 57.6884 and so on, so it can be written as 57.7 degree. And they have asked specifically that alpha correct to 3 decimal places, so we'll write not 57.7, it is going to be 57.688. so this is degree. This is the answer for r and root 7, and this is the answer for alpha. I guess it is okay. Let's do the next part. In the B part it is given hence solve the equation this is equal to 1. So from the first part only we got to know that this was r cos x, that is 2 theta plus alpha, and this will be 1. So from there we can write it as root 7 cos of 2 theta, and alpha is 57.688 is equal to 1. So we can write cos 2 theta plus 57.688 is equal to 1 over root 7, and this will get value from the calculator. 2 theta plus 57.688 as cos inverse of 1 over root 7, and let's find what is the value of this. Cos inverse of 1 over root 7, from the calculator it is coming 67.79 and so on, 92. I'll give the answer afterwards so that we can get it easily. Then this is, I'll marking it is equal to equation number 1 because I'm not finding the theta yet, and we know in the cos the next angle always you get it from 360 minus theta. So if we are doing the 360 minus theta, so we will get it as 2 theta plus 57.688 is equal to 360 minus 67.792, which is 360 minus 67.792, it is coming 292.208. and next value if we'll do that will go out of the range, so we'll only solve for these two values. And how to find, how to decide at range, I use that word. We know that this is 2 theta, so theta is 180, then 2 theta will be in between 0 to 360, and the next if you get add 57.68, so it would be 57.688 and so on. So basically what we are going to do next, for the next angle we will add 360, which is of course more than 360 or more than 400, so that's why I'm leaving it here. So from 1 2 theta is equal to 67.792 minus 57.688, and that is 67.792 minus 57.688, it is coming 10.104, and hence theta is equal to 10.104 over 2, and that is 5.05. Next is 2, so I'll write till 3 significant figure. So theta is equal to 5.05 from first, and from second, because we have another angle, from second we get 2 theta as 292.208 minus 57.688 is equal to 292.208 minus 57.688, it is coming 2234.52, and hence theta will be 234.52 divided by 2, it is coming 117.26. So at last we'll write the value of theta as we know that angle we always write till one decimal place, so it is 5.05, so it is 5.1 degree, and another angle is 117.26, that is 117.3 degree, and that is the answer. I hope it is clear. So let's do the next question. In question number 6, the diagram shows the curve y is equal to x over 1 plus 3x to the power 4 for x greater than equal to 0, and its maximum point is m. Find the x coordinate of m, giving your answer correct to 3 decimal places. We know at maximum place, at maximum point, dy over dx, the gradient is always parallel to x-axis. So the tangent at the maximum point is always parallel to the x-axis. So we'll find dy over dx from here, and then we make it equal to 0 to find the x coordinates. So let's find dy over dx, and we know it is going to be quotient rule, because it's the numerator upon denominator. And I'll tell you the quotient rule again, because I have explained it very nicely in the previous solved paper. Whenever you are doing the quotient rule, you start with the denominator and do the square of it, 1 plus 3x to the power 4 whole square, and write in the numerator as it is 3x to the power 4, and do the differentiation of numerator, that is 1, minus write the numerator as it is and do the differentiation of the denominator, that is 0 plus 3 into 4 is 12 x to the power 3, and that is the dy over dx. We'll simplify one more time, then make it equal to 0, and it can be written as 1 plus 3x to the power 4 minus 0, so it is not required to write 12x to the power 4 over 1 plus 3x to the power 4 whole square, and which can be written as 1 minus, it is like term, so minus 9 x to the power 4 over 1 plus 3x to the power 4 whole square. Now for maximum point, at maximum point we can write at m dy over dx should be equal to 0, and hence it is like 1 minus 9x to the power 4 should be equal to 0, because denominator will never be 0. It is 1 square minus 3x square whole square is equal to 0. So which will give us 1 minus 3x square, in another bracket 1 plus 3x square is equal to 0. So we got two roots. One is x is equal to plus minus 1 over root 3, and from here we'll get x is equal to plus minus negative of square root of negative 1 over 3, which is of course not possible. We'll not take this value because it's not real, and hence we got x is equal to plus minus 1 over root 3. And since we take x is always greater than equal to 0, so x is equal to 1 over root 3, and 1 over root 3 is equal to 0.5775 and all, but we require to give the answer till 3 significant figure, so it is going to be 0.577. So I hope it is clear. Let's do the next part. So in B part, using the substitution u is equal to root 3x square, find by integration the exact area of shaded region bounded by the curve, the x-axis and the line x is equal to 1. So we know the curve is like this, and it is x is equal to 1, and the curve y is equal to x over 1 plus 3x to the power 4, and m was a maximum point, it is not required at all. Now we need to substitute this, but we know what is the meaning of area enclosed by the region. It is denoted by limit from 0 to, because it is going to start from here, 0 to 1 y dx. This is the area enclosed by the curve from 0 to 1, and it can also be written as 0 to 1 and x over 1 plus 3x to the power 4 dx. Now if we substitute u is equal to root 3x square, first of all we will find what is the value of du over dx, that is du can be written as 2 root 3x times dx, and we have x dx in this, so or we can write 1 upon 2 root 3 du is equal to x dx. Now we got everything, x dx also, and x square and root 3. So I'll rewrite it as, so that it can be simplified and easily seen. It is x dx here, and it is 1 plus root 3x square whole square, root 3 x square whole square. So it can be the area, I'll write area as a, this is a, so a is equal to, now we'll put the values of x so that we can change the limits and the x in u directly. If when x is equal to 0, from here we can see that u is also going to be 0. If x is equal to 1, then u is equal to root 3, because when we'll put x is equal to 0, this is 0, and when it is 1, and hence a is equal to this 0 to root 3, and it is du 1 over 2 root 3 will come out, x dx I have written 1 over root 2 root 3 du, and this denominator become 1 plus u square, and now we can see it is 1 over 1 plus u square, that is the integration of this is tan inverse of u, it is going to be 1 over 2 root 3 and tan inverse of u, and the limit is from 0 to root 3, and hence it is 1 upon 2 root 3 outside, and when you will put tan inverse root 3, we will get tan inverse root 3 is pi by 3, because 60 degree, and minus tan inverse 0 is 0, so the last answer is going to be pi over 6 root 3, and we need to give the answer in the exact form, so this is the last answer, or we can write the answer in the rationalized form, because we need not to get the denominator as this, or that is also fine, but if we multiply and divide by root 3, that would also be nice. So pi root 3 upon 3, root 3 into root 3 is 3, 3 6 are 18. So that is the area bounded by the curve and the x-axis, and the line x is equal to 1. So I hope it is okay. So let's do the next question. Here's question number 7. The variables x and y satisfy the differential equation dy over dx as y minus 1 upon x plus 1 into x plus 3. It is given that y is equal to 2 when x is equal to 0. And the question is to solve the differential equation obtaining an expression for y in terms of x. So we can see that there are y together and x together, so we will do the variable separable method here, and we will write it as dy over y minus 1 is equal to integration of dx over x plus 1 and x plus 3. Now we can see that there is a product of two linear factors, so we'll do the partial fraction. So let's find out that first. So it is 1 over x plus 1 into x plus 3. It can be written as a over x plus 1 plus b over x plus 3. So we'll multiply, I'll multiply the whole equation by 1 x plus 1 into x plus 3, and we will get it as 1 is equal to a times x plus 3 plus b times x plus 1, and hence if we put x is equal to, if x is equal to minus 1, we will get b is equal to b coefficient 0. So a times minus 1 plus 3, that is 2. So 2a is equal to 1, and hence a is equal to 1 over 2. Similarly, if x is equal to minus 3, let's put x is equal to minus 3, we will get minus 2b is equal to, because it is minus 3 plus 1 minus 2, minus 2b is equal to 1, and hence b is equal to 1 over 2, minus 1 over 2, and hence this integration can be written as integration of dy over y minus 1 is equal to integration of dx over x plus 1, and a value is 1 by 2, so I write 1 by 2 outside because it's a constant, and minus 1 by 2 of the value of b, and that is dx over x plus 3. And let's integrate this. It is going to be ln y minus 1 is equal to 1 by 2 ln x plus 1 minus 1 by 2 ln x plus 3, and plus constant of integration, it is, let's say, capital C, and then we'll put the value, and we know that at x is equal to 0, when x is equal to 0, y is equal to 2. So let's replace the value. We'll get ln 2 minus 1 is equal to half ln 1 minus, because x is 0, ln 1 minus half ln 3 plus a constant c. Now we know that ln 1, since we know ln 1 is always going to be 0 for any base actually, but it is ln, so base is e, so it become, this is 0, this is 0, and c is equal to 1 over 2 ln 3. So it is the value of c now. Now we'll replace in the equation, and we'll get ln y minus 1 is equal to 1 over 2 ln x plus 1 minus 1 over 2 ln x plus 3 plus 1 over 2 ln 3. Now we can see there is a subtraction and there is addition, so we'll use the log property, and taking 1 over 2 common, we can write it as ln, and these two are additions, so 3 times x plus 1 and divide by, because it's a minus, divide by x plus 3, and hence we got it as, let me scroll it, we got it as 2 times ln or let me write it there only. It is ln y minus 1, and since it is a multiplication with 1 over 2, and then it will go in the power and it will become 3 times x plus 1 over x plus 3 and whole to the power 1 by 2, and hence the last answer y minus 1 will be square root of 3x plus 3 over x plus 3, or we can say y in terms of x is 1 plus square root of 3x plus 3 over x plus 3. So this is the last answer. It's not required to solve from here, but I have started from here. We could have simplified here this like x plus 1 upon x plus 3, and 1 over 2 can be like you can transfer it here also, that multiplied by 2 here also, that is always going to be same. It will always come with the same answer. So I hope it is clear. So we'll discuss the next 3 questions, 8th, 9th, 10th in the next video. Till then, thank you so much.